Assalamu alaikum friends, my name is Bilal Khan and this is my 7th video of DevOps. So in this video I am going to show you the TCP IP model. So in the previous video I have taught you what is the OSI model. So in this video I am going to show you what is TCP IP model. So the TCP is a transmission control protocol / internet protocol. It's a concise version of the OSI model. So it's a concise or a shorter version of the OSI model. Basically it contains 5 layers only, unlike 7 layers in the OSI model. So the OSI model were containing 7 layers, but this model is containing 5 layers only. Another thing you need to remember, and that is the TCP IP model is used for practical purpose and the OSI model is used for theoretical purpose. So if you want to study the layers of all the layers, you need to study the OSI model. But for practical purposes, the TCP IP model is used. Alright, so here are the layers of the TCP IP model. As you can see that here is the application, transport, network, data link and physical layer. Alright, so these are the layers that are used in the TCP IP model. So let's jump into the first layer of the TCP IP model. The first layer is the application layer. As we have seen in the previous video also, that the application layer is commonly used for user interaction. Alright, and the example of this application layer is WhatsApp, browser or any other application through which a user can interact. And now where this application layer is used, it is used in the devices. It may be a laptop, it may be a mobile or desktop, any device through which a user can interact. Now these application layers are using protocols. So we have discussed in the previous videos that what is protocol. Basically these are the set of rules. Alright, but we have not discussed the client and server architecture. So let's discuss it. So the client server architecture is used by the TCP. Alright, so TCP IP uses the client server model of communication. Alright, so this model has two parts. Alright, client part and the server part. So these parts will run different processes. With the help of these processes, they will communicate with each other. The client uses some process and the server uses another process. Alright, so with the help of these processes, they will communicate with each other. Now let's take an example that how the client and server architecture will work. So basically here is a client that will send a request to the server. Alright, so let's say a client send a request to the server to access a Google web page. Now the server will find the Google web page in itself, and then after finding it, it will give the response back to the client. Alright, so the client will see the Google web page in its browser. So this is the model of client-server architecture. The client will send a request and the server will find the data and give back the response to the client. Alright. So after that, let's discuss what is client and what is server. So client is a computer hardware device or a software, alright, that accesses a service made available by a server. Alright, so it will access a service, any type of service. It can be a web service, it can be a file service, it can be a database service. So all the services that the client wants to access will be present in the server. So it will access that service made available by the server. After that, a server is a physical computer dedicated to run services. Alright, so these are the services. The services will be run on the server. So to serve the needs of the other computers. So the other computer means the client. Alright, depending on the server that is running, it could be a file server, database server or a web server. Alright, so the client will send the request to access a file server, database server or a web server or any other server. So that server will respond back to the client. So the collection of servers present in a big company called data center. Alright, so there are a lot of servers. The company is not using just one server, so they have a bunch of servers used for different purposes. So they collectively are called data center. Alright, so after that, let's move to the TTL or time to live. But before discussing this TTL, let's show you a terminal. What is TTL? Let's close this slideshow and open the terminal and now write ping google.com. Alright. So as you can see that these are the packets received to my terminal from google.com. Alright. So what are these packets? So as we have seen in the previous videos, that the data will be received in the form of packets or chunks. So data will be not received as a whole, but basically it will be divided in the form of chunks. So these are the chunks or the packets that will be combined to form a google.com. Alright. So every packet has a 64 byte size, and it is received from this website, and it has a server IP address. Alright. So Google not only contains just one server, Google contains a lot of server, and every server has its own IP address. So this IP address belongs to one of the server. Alright. So this packet has this IP address. Alright. As you can see that here is the ICMP sequence. So we have seen in the previous video that what is the sequence number. So the sequence number will align the packets based on its number. Alright. So that it cannot be randomly used or randomly received. So with the help of this sequence number, the data will be received one by one. Alright. So now let's move to the TTL, but let's skip it first and move to the time. So the time is basically the ping time. I will show you the definition in the slideshow also, but you need to remember that the time is basically showing us that how much time it took for google.com to be received to us. Alright, so it took 172 milliseconds to receive the data of this packet. Alright, so for this packet 152 milliseconds it took. Alright, so now let's move to the TTL and go back to the browser and open the slideshow. Let's take an example of a router. So we have seen in the previous video also that router will route the data based on its particular location. So basically, let's say if a network 1 on device 1 send a request to the router will only send the response back to the network 1. Alright, it will not randomly distribute that response to all the networks. It will only send the response back to the network 1 only. Similarly, if the network 2 send a request to the router 2 will only respond to that network 2 only. Alright, so similar case with the network 3. So these are the response that will be sent in the form of packets. So let's say for the network 1, the packet 1 will be sent. For network 2, the packet 2 will be sent, and for network 3, the packet 3 will be sent. Alright, so let's say I have a packet 5, and that is trying to be sent in the networks. But here you can see that there are only 3 networks are present, and the packet is not belonging to any of these networks. So how the router will handle this packet 5? So basically it will create a default router. This default router will be used to take the packet 5. Alright, so default router is used for all the packets that are not belonging to any of the networks. Alright, so it will take this packet. So let's take another example. As you can see that I have a router 1, router 2 and router 3. And packet 5 is trying to access to this router 1. Alright, so now it is not accepting this packet 5 because router 1 is only connected to, let's say, 1 or 2 or 3 networks. Alright, so it is not belonging to this router. So what the router will do? So in this case the router 2 will be the default router of the router 1. As we have seen that the router 1 was the default router of the main router. So in this case the router 2 will be the default router of the router 1. So the packet 5 will be transferred from router 1 to the router 2. Alright. So in this case now the router 2 will also be not accepting the packet 5 because it is also connected to some other networks. So in this case the router 3 will be the default router of the router 2. So the router 2 will transfer this packet to the router 3. Now the router 3 is also not accepting this packet 5. So in this case, the router 1 will be the default router of the router 3. Alright. So after that, the router 3 will send the data back to the router 1. Now there is a loop created. As you can see, there is a cycle that has been created, and the packet is not staying at one place. It is moving from router 1 to router 2 to router 3. And this is continuing, and this will go on and on. So how to solve this problem? How to stop this loop? So basically, the TTL is used for this purpose, to stop this loop. Alright. So now let's take an example of TTL to show you what it will do and how it can stop this loop. So here you can see that here is a sender, and it is trying to send a message to the receiver. But here are two mediums through which the packet will pass. Alright, when the packets will pass through these mediums, it will reach to the receiver. So let's say I have a TTL. Alright, so for this purpose the TTL will be created. So I have make it equal, the TTL is equal to 3. Alright, so you can make it equal to any number, but I make it equal to 3. So what does it mean by 3? So the 3 means that it will jump 3 times, or it will make 3 hops. Alright, so in this case the jump will be taken from sender to the X. Alright, and now the TTL value is equal to 2, because one jump has been taken. Alright, so after that let's jump again, and now the TTL value will be equal to 1. Alright, now only one jump is remaining, so let's jump again, and now the TTL value is equal to 0. So now it has jumped 3 times to reach to the destination. Alright, it has passed all the mediums, and it is finally reached to its destination. Let's take another example. Let's say that I have a packet TTL is equal to 2. So in this way it will jump 2 times only. So the sender will jump from sender to the X. Alright, this is the first jump, and the TTL is equal to 1. Now it's jump again from X to another X, and the TTL value is equal to 0. Because the data is not reached to the X receiver, so the TTL is equal to 0. Now the packet will get discarded here. Alright, so it will not be reached to the receiver, so the packet will discard here. But here in this case the packet has reached, and this way the TTL will also be get discarded. Alright, so apply this example to this example. Alright, so let's say that I have a sender. Alright, and this sender is trying to send a packet, and that packet is equal to 5. Alright, and this sender is trying to send a packet to the router 1. Alright, so let's take the TTL equal to 5. Alright, so let's take this TTL equal to 5. It has a packet 5, and let's take the TTL also equal to 5. So it jumped from sender to the router. So now the TTL will be equal to 4. Alright, after that let's jump again from router 1 to the router 2, and now the TTL value is equal to 3. Alright, after that let's jump again from the router 2 to the router 3, and now this time the TTL is equal to 2. After that jump again, the TTL value is equal to 1 when it is jumped from router 3 to router 1. Right, but now it is showing us that one jump is remaining. So let's jump from the router 1 to the router 2 again. In this way the TTL value is equal to 0. So now the loop has stopped, because the TTL value is equal to 0. So it has jumped 5 times, and the packet has reached to the router 2. But in this way the packet will get discarded due to the TTL is equal to 0. So in this way you can stop the loop of this packet. Alright, so let's close this slideshow and move back to the terminal. As you can see that the TTL is equal to 116. So it will jump 116 times to close the loop, to stop the loop, alright, and discard the packet. Alright, so this is the purpose of TTL. Let's move to the slideshow. Now you can see that it is showing me the definition of ping. So ping is a signal sent to the host. Host may be a google.com, amazon.com or any other website. So a ping will send a signal to the host that requests a response. Alright, so you are trying to request a response from a google.com. So you will send that request to your host or google.com. So it serves two primary purposes. Number one, to check if the host is available. Alright, so it will check if the google.com is available. And the second is to measure how long the response takes. So it will basically check how much time it took to respond to us. Now this time will be measured in milliseconds, and this time will be called ping time. So the time it takes for a small data set to be transmitted from your device. So you send a request to the server on the internet, and that server respond back to your device again. Alright, so this time will be called ping time. You send a request and the server responded back to you. So this time will be called ping time. The ping time is measured in milliseconds. Alright, so there is another way through which applications are connected from end system. So this way is called peer-to-peer architecture. So here you can see that this is the peer-to-peer architecture. So one device is connected to the second device, second is connected with the third device is connected with the fourth device. So this process is going on, and this will repeat, it will not end this process. Alright, so every computer is connected to its own, to another device. So now the question arises that where is the client or where is the server? So the peer-to-peer architecture is providing a functionality, and that functionality is this, that every device is working as a client and as a server also. Alright, so one device will work as a client and as a server both at the same time. Alright, so in this way the one device is performing the functionality of the both. So it has a disadvantage, and that is decentralized system. So one device is performing the functionality of both the client and the server, so it is not dependent on another external server. So this is the advantage of the peer-to-peer architecture. So there is another architecture also, and that is hybrid network architecture. So hybrid network architecture, basically it's a combination of peer-to-peer and client-server architecture. It will do both of the functionalities of the peer-to-peer and client-server architecture. So every device will be connected to each other, and they will share the data, and in this way the external server will also be present to share the resources. Alright, so hybrid networks are the networks that are based on peer-to-peer and client-server relationship. Hybrid networks provide all the centralized service of the servers. So there will be a centralized server also that will be outside of these devices, but they also allow users to share and manage their own resources within the group. So they will also share those resources within the group by using the functionality of the client server in their own device. Alright, so there will be an external server, and there will be a server present within their self. Alright, so this is the functionality of the hybrid architecture. So now let's close this slideshow and let's go to the some devices definition. These are some of the networking device that is important to know that, and the first one is the repeater. So let's zoom in. Now it's good. So the repeater operates at the physical layer. Alright, so basically, as we have seen in the previous video, that what is physical layer, you already know that. So basically it works at the physical layer. Its job is to regenerate the signal over the same network before the signal becomes too weak. So it will generate the signal over the same network before it becomes too weak or corrupted. Alright, so it extends the length to which the signal can be transmitted over the same network. An important point to be noted about repeaters is that they do not amplify the signal. When the signal becomes too weak, they copy the signal bit by bit and regenerate it at the original strength. It is a two-port device. Alright. So there is another network device, and that is hub. So hub is basically a multi-port repeater. So it has multiple ports. Alright, a hub connects multiple wires coming from different branches. Alright, so this is providing a functionality to connect multiple devices within itself. Alright, so this is the functionality of the hub. These are the type of hubs, you can study it. So another device comes, and that is bridge. So bridge operates at the data link layer. We have discussed in the previous video that what is data link layer. It is basically working on the MAC addresses. So basically the bridge is a repeater with the add-on functionality of filtering content. So it will basically filter the content by reading the MAC address. Alright, so it will make sure to identify the devices based on the MAC address, and this will identify that what is the source and what is the destination from which the data is transferring and from where data is trying to receive. Alright, so this is basically identifying the data and identifying the devices based on the MAC address with the help of bridge. So these are the type of bridge, and the next the next device is switch. So switch is a multi-port bridge. Alright, so it has multiple ports with a buffer and a design that can boost its efficiency. So it will boost the efficiency and the performance. Alright, so this for this way it is used, and it has multiple ports. Alright, so it is a multi-port bridge. So after that, let's move to the router. The router is a device like switch. Alright, we have discussed in the previous video that router will route the data based on the IP address to identify an application. After that, the gateway, as the name suggests, is a passage to connect two networks together that may work upon different networking models. So it will connect two networks that are working with different networking models, and it will provide a passage. Alright. So after that, let's move to the router. So the router is, as the name suggests, that it is working as a bridge and a router. Alright. So it is the bridging router is the device that combines the features of bridge and the router. Alright. So we have seen that what is bridge. So bridge, let's move above. And bridge, as you can see, that it is working on the data link layer by identifying the device based on the MAC address. So it will identify the device based on the MAC address, and it will also route the data based on the IP address. The last one is the NIC. It is the network interface card. It's a network adapter that is used to connect the computer to the network. Alright, so this will connect the computer to the network. It is installed in the computer to establish a lane. So with the help of local area network, it will be installed, and the computer will be connected to our network. So now let's move to the slide again. And now let's discuss what is protocols. So in the previous video we have discussed what is protocols. Basically these are the set of rules through which the communication will happen. Alright. So the first protocol is the TCP IP protocol. Alright. So the TCP IP is a set of standardized rules that allow computers to communicate on a network such as the internet. Alright, so with the help of these rules, the computer will be communicating on a network, alright, such as the internet. So these are some of the protocols that you need to remember. The first one is the HTTP. This is a hypertext transfer protocol. These are commonly used in the browser, alright. And DHCP, Dynamic Host Configuration Protocol, it is used to assign the local IP addresses to the devices. We have seen previously in the videos also that it will assign the local IP addresses to the devices. Now the FTP comes in picture, and the FTP is a file transfer protocol. It will handle the file transfer. Alright, so it will transfer the file, so with the help of these protocols. But these are not used nowadays. the functionality of this is used in the HTTP also. So SMTP protocols. So the SMTP is a simple mail transfer protocol. This will allow the email to be transferred with the help of these protocols. All right. So the email will be transferred with this SMTP. So how to receive these emails? So to receive this, the POP3 and IMAP protocol will be used to receive the emails. After that, the SSH protocol, secure shell protocol, comes in between in the picture, and that is trying to log into another computer terminal. All right. So if you want to access the another computer terminal, if you want to log into someone else's computers using the terminal, the SSH will be used. This is a important protocol. This is very important. So after that, the VNC, virtual network computer protocol, comes in picture. So basically, it's a graphical desktop system that will allow the computer to remotely access another computer. Alright, so it will remotely access another computer. So now let's move to another page, and here is the telnet. So basically, it is after the TCP IP, the telnet comes in picture. The telnet is a networking protocol and software program used to access remote computers and terminals over the network. Alright, so it will access the remote computers or terminals over the internet. So it manages the account or devices remotely. Alright, so you are sitting here and you want to access someone else's computer on the terminal, the telnet will be used. It is working on the port 23. UDP we have discussed already. UDP is a user datagram protocol. It is a connectionless or stateless protocol. Basically, it does not maintain the state of the data. That's why some data may be lost in this protocol. The best example of this is video conferencing, because all the frames will not be maintained at that time, or some frames will get lost in this protocol. So it is very fast because it is not maintaining the state of that data. Alright. So in this way, the data will lost in this protocol. So now let's discuss what is process and threads. So the process are basically the programs which are dispatched from the ready state and are scheduled in the CPU for execution. Alright. So these are the programs. Basically the process is basically the programs that will be in the ready state but are scheduled for execution. Alright. So they are ready to be executed. Alright. So these programs are called processes. But the thread is different than that. The thread is a segment of that process. Alright? Means a process can have multiple threads, and these multiple threads are contained within a process. Let's take an example of the data that we have used. The data will be divided in different packets. So similarly, the process or a program that is ready to be executed is divided into different threads. Alright, so these threads will combine to form a process. Alright, so let's take an example. Here is a program WhatsApp, and it is performing different processes. The first process is a send a message. The second process is recording a video. So these are the process that is ready to be executed. If you want to send a message, you will simply open a WhatsApp messenger or record a video. If you want to transfer that, if you want to record a video. But the thread will set up the page. So to send a message, it will first set up the page, or to record a video, it will first open the camera. So these are the things that will help to execute this process, or the thread will help to execute a process. So for message, the page will be set first of all, and to record a video, the camera will be first open. After that, the next step is to enter the text also, because without entering the text, you can't send a message. Alright, and without opening the night mode or any other mode, you can't record a video. Alright, so in this way, the process the threads will be helpful to make the process done. Alright, so I hope you understood this. So now let's move to the socket. So socket is a two-way communication between softwares. Alright, so it running on a network. So basically it is possible, it is basically making us to communicate with each other over the network, but it is not a client-server architecture. It is a software that will help us to communicate with each other on the network. Alright, so basically it's an interface between a process and the internet. So between the process and the internet, the socket will be used. So it will establish the two-way communication with the help of software. It will not be in the hardware. Alright, so it is not the client-server architecture type of thing. So socket is identified by an IP address concatenated with the port number. Like this is the IP address, let's say, and this is the port number. So with the help of these, this string or this combination will make a socket. Alright. So the IP address will be used to identify the device, and the port number will be used to identify an application. So with the help of this IP address and port number, the communication will happen. Alright, so this is the socket. So the socket will be identified by these two strings. So now let's move to the port. So the port is this number. Alright, so we have seen already that the port are used for identifying an application. Alright, so if you want to identify an application, let's say the browser send a request to someone else. So how the browser will be identified? Because the IP address is identified, but now the application is not identified. So to identify an application, the ports will be used. Alright. After that, let's take the example of, let's take a definition of ephemeral ports. Alright. So what the ephemeral ports will do, now the application is identified that this browser has sent a request to another computer. But the browser is identified using the port number, but how the tab will identified, how the instance in that browser will be identified. In this way, the ephemeral ports will be used, because the ephemeral ports are used for identifying the instances or the small data, the small parts of an application. Alright, so this part of an application send a request to another computer, because one application may contain different parts through which the request will be made. Alright, like one browser application contains many tabs. For each tab, separate ephemeral port will be used. Alright, one tab, first tab send a request, or a second tab send a request. So this will be identified by ephemeral ports. Alright, so what we have learned today, I have learned the TCP/IP model, and I have also shown you what is the TCP/IP model and the first layer of it, the application layer. We have not discussed other layers of the TCP/IP model. We will be discussing about in the later of this in the upcoming videos. After that, the client server and the peer-to-peer architecture is discussed, and the hybrid architecture is also discussed. Alright, so what are these architectures? After that, I have discussed what are the web protocols and what are the different type of protocols that are used to communicate with each other. And after that, the process, threads and ports are discussed. So what are the process, threads and what are the ports that will help to communicate with each other. Alright, so these are some of the things that we have learned today. So that's it. I hope you like this video, and if you like it, please make sure to subscribe to my channel, and if you have any questions, then ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.